We're going to use what we know about similarity to find angles that should be congruent, and then also end up writing a statement of proportionality. So you've got these two triangles here that look like they are similar. This one obviously looks a little bit larger. And here's our similarity statement that says triangle ABC is indeed similar to triangle LMN. So the first thing that we're going to do is write out three congruent statements for the angles that correspond with one another here. It looks like A and L go together. It looks like C and N, B and M go together because they're kind of laid out the same way. But before you attempt to show the angles are congruent that way, you really should be going back up here to the similarity statement to double check that, just in case the diagram's not quite right. So in the similarity statement, I see that A is my first letter, L is my first letter in this triangle. That means that A and L go together, not just because they look like it down here. Okay, so A is congruent to L. I should put angle A and angle L, sorry. Same thing here. I'd look at C and N, and I think those go together, but really the reason they do is because it's written in the third spot up here. So angle C and angle N. And then finally B and M, because they are in the middle of those similarity statements. Angle B is congruent to angle M. Okay, so those are three angles that we know are congruent because the triangles themselves are similar. The last part of this is that we want to write a ratio having to do with the sides in a statement of proportionality. A statement of proportionality just says, well, this ratio is congruent to this ratio. This ratio is congruent to this ratio. So I'd look at that, and again, this side seems like it matches up with this side, not just because it looks like they're oriented that way, but because AC, which is the first and third letters within that triangle, matches up with L and N. Okay, so I'm going to keep it doesn't really matter which way you do this, but I'm going to keep this smaller triangle, those side lengths, as the numerator when I write the proportions. So I'm going to put AC up at the top here, and I'll put LN as the denominator. And I'm going to say that because these triangles are proportionate, because they're similar, that ratio from the smaller triangle to the larger triangle should be the same as if I do another ratio from a different set of sides that correspond. So I'm going to say AB from the first triangle and LM from the second triangle, this one and this one. Again, not just because they look that way. Here's AB, here's LM. And then finally, that's also true about the third ratio when I'm looking at that third set of sides. So the bottom side, CB, NM. CB over NM. Okay, so that is my statement of proportionality. Those ratios are the same. And what we could have done, we could have written those in reverse. So we could have had the numerator as the denominator, denominator and the numerator. So we could have had LN over AC. We could have said LM over AB and NM over CB. That would all still be true as well.